Hi there, this is Elaine and welcome to my channel. Today we'll talk about some general information about forces and motion. Talking about forces and motion, are there a lot of questions popping up? Like what makes things move? What makes a car speeding up or slowing down? How do forces affect motion, etc., etc.? Well, think about it and I trust you will figure it out. Okay, first off, what is force? A force is a push or pull. A force is required to change the motion of an object. For example, the force you exert on the pedals of a bike makes the wheel turn. In a car, the force behind the motion is the engine. And here are some common types of forces. Magnetic force exists between magnets. Gravity force is the force Earth pulling you down. Friction force is between the surface and the object. Applied force is how much force you apply on an object. Tension can only be a pull, not a push. Normal force is always perpendicular to the surface. Remember, force always has a magnitude, which shows its size, and its unit is in newtons, and direction. Force can set an object in motion, change the speed of an object, change the direction of motion, and even change the shape of something. Some examples of how we express the magnitude and direction of force are listed below. We can say force F is equal to 100 newtons to the right. In this case, the magnitude is 100 and direction is to the right. Or we can say force is equal to 100 newtons, 30 degrees north of east or west of south, depending on its situation. And next, we'll talk about motion. And how does it relate to forces? Motion is the change of position. In other words, anything moving is in motion. For example, the earth revolving around the sun's motion, and anytime your position changes, you are in motion. Also, motion is relative, i.e., it's always described in relation to a reference point. For instance, the Earth orbits the Sun at a speed of 67,100 miles per hour, or 30 kilometers per second, but we can't feel it, right? Why? Because the reference point is different. If the reference point is the Sun, i.e., from the Sun's point of view, the Sun sees Earth going around it. However, if we humans are the reference point, i.e., from our point of view, what we see is that nothing is moving, because everything we see around us is rotating along with the Earth. So if we look at it from different reference points, the motion is going to be different. So how does the force and the motion relate to each other? To answer this question, let me introduce Newton's first law of motion. He said, an object in motion will remain in motion, and an object at rest will remain at rest, unless there is a force acting on the object. Let me tell you an example to explain this. Imagine a soccer ball is laying on an open field. It will remain sitting there unless an outside force acts on the object, like someone kicking the ball. Once the ball is in motion, it will remain in motion unless an outside force acts on it, like friction force between the ball and the grass will eventually stop the ball. Wow, we learned a lot today. Good job. That's the end, and may the force be with you. Thanks for watching. Subscribe for more video.